Hey, what's up guys, this is Dr. Vivek Palipuram bringing you the next lecturette in ENGR 250 Probability and Statistics for Engineering and Computer Science. In this lecturette, I'm going to cover the law of total probability and we are going to see how to use the law of total probability to solve different probability problems. The law of total probability is used in one specific case wherein you would like to find probability of an event A if it were to come from different sources and those sources themselves have certain probabilities of being selected. Now let me put these words into actual picture so that you are able to visualize the law of total probability. Let's say that I am interested in finding the probability of event A. Further assume that event A can come from one of these three sources, B1, B2, and B3. Further assume that these sources themselves have probabilities of being chosen in order to give you the event A, meaning that probability of B of 1 gives you the probability of selecting the source B1, probability B2 gives you the probability of choosing the source B2, and similarly P of B3 gives you the probability of choosing the source B3. Further, assume that B1 produces numerous number of events out of which a fraction corresponds to A. Similarly, B2 produces numerous events out of which a fraction corresponds to event A, and similarly B3 produces numerous events out of which a fraction is produced, which is your event A. Now, if I'm interested in getting the event A, I can get it from B1 and it produces the event A, or I can choose B2 and I get A, or I can choose B3 and I can get A. And if I were to put this in probability terms, in order to find probability of event A, I can get probability of B choosing B1 and I get an A, or translates to a plus, probability of B2 and A, or here translates to a plus, probability of B3 and A. So essentially what I have done is I have added all of these probabilities. I am considering the total probability, and therefore it is called as the law of total probability, where your event can come from multiple sources and these sources themselves have certain probabilities of being chosen. Now remember, or in English translates to a plus in mathematics, specifically in probability mathematics, and translates to the intersection operation. So I can write probability of event A as probability of A intersection B1 plus probability of A intersection B2 plus probability of A intersection B3. For problems pertaining to the law of total probability, these terms are rarely given to you directly, but they are given to you indirectly. For example, a problem statement may directly give you the probabilities of choosing these sources. P of B1, P of B2, P of B3. These may be given to you in the problem statement. Additionally, the problem statement may also give you the fraction or the probability of getting the event A given that a source is selected, meaning in the problem statement, it may be given to you what is the probability of event A given that source B1 was selected. So essentially, I'm giving you here what fraction of items produced by B1 correspond to the event A. Similarly, it may be given to you what's the probability of event A given B2 was selected and what's the probability of A given B3 was selected. So these items may be given to you in the problem statement, and we have to use these items and plug it in this equation somehow. Now, based on the conditional probability formula, you have probability of A given B as probability of A intersection B, or probability of B, which implies that probability of A intersection B is equal to probability of A given B times probability of B. Using this form right here, I can substitute it in this equation. So the very first term, I can write it as probability of A given B1 times probability of B1. The second term, I can write it as probability of A given B2 times probability of B2 plus probability of A given B3 times probability of B3. So using this equation, which is my law of total probability, I can solve probability problems that relate to law of total probability. You can pause your video here, or you may want to revisit this entire slide one more time before we proceed any further. let's proceed further and really conceptualize when to use the law of total probability. The law of total probability is used in the following case. When the desired outcome, let's say A, if it may come from multiple sources, let's say B1, B2, B3, with certain probability, meaning probability of A given B1, probability of A given B2, and so on. And these sources themselves have probability of being chosen, meaning that I will have probability of B1, I will have probability of B2, and so on. Then in that case, you should apply the law of total probability. So a law of total probability is used when a desired outcome may come from multiple sources and those sources themselves have probability of being selected. For example, consider this case of purchasing a laptop from one of the Best Buy warehouses, specifically from the Stockton's Best Buy. Now let's say that I go to Stockton's Best Buy and I'm interested to purchase a laptop from there, and I'm interested what's the probability that a laptop that I picked up is good, or if it is an acceptable laptop. Further assume that Stockton's Best Buy gets its laptops from 3 warehouses, one from Fremont, one from San Jose, one from San Mateo. Furthermore, these warehouses provide different number of laptops to the Stockton's Best Buy. So if I were to pick a laptop from Stockton's Best Buy, there's going to be certain probability that it may have come from Fremont. Similarly, it's going to have certain probability that it may have come from San Jose or San Mateo. Further assume that this laptop may be either good or bad from these different warehouses. Specifically, let's say that Fremont supplies certain fraction of laptops which are considered good or acceptable. San Jose sends a certain amount of laptops that are considered acceptable, and similarly San Mateo sends certain amount of fraction of laptops which are considered acceptable. So if I were to pick a laptop and if I'm interested in finding whether this laptop is acceptable or not, I'm going to use the law of total probability, because the desired outcome, acceptable laptop, is coming from these different sources, and these different sources themselves have probabilities of being chosen because they sent different number of laptops to Stockton's Best Buy, and therefore when I pick a laptop at Stockton's Best Buy, there's going to be certain probability that may have come from one of these warehouses. So I'm going to apply the law of total probability right here. So an acceptable laptop may be, or a laptop may be acceptable and it may come from Fremont, or it may be an acceptable and it may come from San Jose, or it may be an acceptable laptop and it came from San Mateo. If I were to use conditional probability formulas, I can rewrite this equation in this form, which is usually called the law of total probability equation. Now the theory of law of total probability will become much more clear if we were to solve some problems. So let me solve some example problems for you. Consider this example. A company has 3 machines B1, B2, and B3 producing resistors. 80% of resistors produced by B1 are acceptable, 90% of resistors produced by B2 are acceptable, and 60% resistors produced by B3 are acceptable. Each hour, B1 produces 3,000 resistors, B2 produces 4,000, and B3 produces 3,000. What is the probability of shipping a successful resistor? So if I were to pick a resistor, what is the probability that it's a good one? Now, law of total probability can be applied in this case because this resistor, a good resistor, it may come from 3 different sources, and these sources themselves have probabilities of being chosen. Because here, B1 produces 3,000, B2 produces 4,000, and B3 produces 3,000. So if I were to put the resistors produced by B1, B2, and B3 into a bin, and if I were to pick a resistor at random, there's going to be certain probability that it came from B1, B2, and B3. Specifically, it's given to you that probability of B1 will be 3,000 out of 10,000. Because if I were to pool all of these resistors together, I will have 10,000 overall resistors, out of which 3,000 resistors will belong to B1. Similarly, probability of B2 will be 4,000 over 10,000, and probability of B3 will be 3,000 out of 10,000. So these are the probabilities of selecting these sources. Now I'm interested in getting an acceptable resistor. I can get an acceptable resistor if I were to choose B1 and get a good resistor. I'll use A as an abbreviation for acceptable, Or I can choose B2 and get an acceptable resistor, or I can choose B3 and get an acceptable resistor. So probability of an acceptable resistor is probability of B1 and A. Remember, intersection is your logical AND. Or is plus probability of B2 and A plus probability of B3 and A. If you notice, these terms are not directly given to you in this problem statement. Instead, you're given the probabilities of events B1, B2, and B3, or specifically probabilities of choosing these sources. You're also given probability of getting a good resistor given a source. For example, read this line right here. 80% resistors produced by B1 are acceptable. This line is actually giving you probability that a resistor is good given that it is from B1, and that is 0.8. Similarly, 90% resistors produced by B2 are acceptable, so that's giving you the probability of that a resistor is good or acceptable given that it is coming from B2. Similarly, 60% by B3 are acceptable, so this gives you the probability of A given B3. So I can rewrite this equation somewhere here. Let me write it like this. Probability of A is equal to probability of A given B1 times probability of B1 plus probability of A given B2 times probability of B2 plus probability of A given B3 times probability of B3. I have obtained the values, the numerical values of all these individual terms. Specifically, probability of A given B1 is 80%, so that's 0.8. Probability of B1 is 0.3 from here, plus probability of A given B2 is 90 or 0.9. Probability of B2 is 0.4 from here, and similarly probability of A given B3 is 0.6. Probability of B3 is 0.3. So if I were to perform this math, I'll get 0.24 plus 0.36 plus 0.18, which gives me 0.78. So if I were to pick a resistor at random, there's 78% chance that it's a good resistor. In this way, you apply the law of total probability equation or theory whenever you are interested in an outcome that can come from multiple sources, and those multiple sources themselves have certain probabilities of being chosen. You can pause your video here, and you may want to replay this example just one more time so that the law of total probability concept is clear to you. Once you're ready, you can unpause your video and we can move on to the next example. Okay, so here's the next example, and I would like for you guys to work on this example on your own first, sincerely, and then you can unpause the video and look into the solution. You have two biased coins A and B. Coin A comes up heads with probability 1 over 4. Coin B comes up heads with probability 3 over 4. However, you're not sure which is which, so you choose a coin randomly and you flip it. If the flip is heads, you guess B, otherwise you guess A. What is the probability that your guess is correct? Carefully observe that this can be solved using the law of total probability because my event is guessing the correct item, and it can come from different sources. It can come from either source A, coin A, or source B, coin B. So you can try to apply the law of total probability right here, and then I'm going to give you the solution once you're ready. Okay, I hope you guys got the chance to work on this problem on your own. I'm interested in the event guess correct. Let me abbreviate it with a C. Now C can come in one of these ways. I select coin A and I choose tails because my guess is correct if I choose tails and it is coin A. Or I choose coin B and choose heads as my outcome. Or rather, let me rewrite the statement one more time. I can get a correct guess if I choose tails and I flipped A, or I choose heads and I flipped B. if either of these two were to happen, my guess would be correct. So my probability will be equal to, probability of a correct guess will be equal to probability of tails and A plus, or translates to a plus, probability of heads and B, and translates to intersection. So probability of event C, the correct guess, will be probability of tails and A plus probability of heads and B. Now these are not directly given to you in the problem statement. Instead, it's given to you that the coins are chosen at random. So probability of choosing a coin A will be 1/2. Probability of choosing a coin B will be 1/2. Further, it's given to you that probability of tails, given that you get given that you flipped a coin A, is 3/4. Because A turns up heads with probability 1/4, so it will come up tails with probability 3/4. Similarly, B gives you tails or gives you heads with probability 3/4. So probability of heads, given that you chose coin B, is 3/4. So I can write this equation something like this: probability of A given, or rather, probability of T given A times probability of A plus probability of heads given B times probability of B. So I have these individual terms right here. So I'm going to just plug and chug. So probability of T given A is 3/4. Probability of choosing coin A is 1/2 plus probability of heads given B is 3/4 times probability of choosing coin B is also 1/2, because I do not have a bias while I choose a coin. I choose a coin at random. So it's a reasonable assumption to assume that probability that I choose coin A is 1/2 and probability that I choose coin B is also 1/2. And when I solve this, I get the answer 3/4. So that's the probability of guessing correctly. Okay. So with these two problems as your motivation and as your guide, what I would like for you guys to do is solve this problem using the law of total probability. And this is one of the problems that you need to turn in for your Thursday's class. So please work on this problem neatly and upload a nice PDF for me to grade. I think it's a good time to stop this lecturette right here. This lecturette introduced you to the law of total probability, which can be a little bit tricky concept to understand. So if by the end of this lecturette, if you feel that it's a little bit tricky to understand and to apply, but I can still do it, don't despair. There's another useful technique that will make you feel that law of total probability is totally easy peasy. And that technique is what we call tree diagrams, because tree diagrams figuratively show you how an experiment is conducted, and it helps you find probabilities of different events by applying the law of total probability implicitly. So some of the problems that we discussed in today's class, they are much more easily solved using tree diagrams. So please look into my next lecturette on tree diagrams, because it will make you feel that law of total probability is totally in your pocket. Adios, guys.